Assume that women's heights are normally distributed with the mean given by mu equal to 64.4 inches and a standard deviation of 2.9. If one woman is randomly selected, find the probability that her height is less than 65 inches. So the probability that x is less than 65 is what we're looking for. So we have a normal distribution with a mean of 64.4 and a standard deviation of 2.9, and we're supposed to find the probability that x is less than 65. So that's what the picture would look like. And in order to find this probability, we're going to have to calculate a z-value, and we'll use the formula z equals x minus mu over sigma. So we'll have 65 minus 64.4 divided by 2.9, which will give us 0.21 when we round to 2 decimal places. Now we can use the calculator in StatCrunch. So we'll click StatCrunch, Stat, Calculators, Normal. We'll leave the mean at 0 and the standard deviation at 1 since we have calculated a z-value. That z-value was 0.21. We'll leave this at less than or equal to since that's what we had in our picture. Hit compute, and we have 0.5832. So this probability will be 0.5832. Or in other words, that area from this mark over, from where x is 65, all the way over into the tail, is 0.5832. Now the next question is, if 48 women are randomly selected, find the probability that they have a mean height less than 65. Now the difference between that question and the question we just answered is the fact that we have a group of 48 women, and we're supposed to find the probability that the sample mean is less than 65. Not the probability that an individual data value is less than 65, but rather the probability that the mean for that group of 48 women is less than 65. So we have a mean of 64.4, but now we're going to be working with the standard deviation of the sampling distribution, which will be the standard deviation divided by the square root of the sample size. Now, we're looking for the probability that the sample mean is less than 65, not that an individual data value is less than 65. So when we do our calculation for z, we'll have x bar minus mu instead of x minus mu, and sigma over the square root of n instead of just sigma. So our z value will be 65 minus 64.4 divided by 2.9 over the square root of 48. And when we perform that calculation, we're going to have 1.43. So we go back to our calculator here. Again, we've standardized, so the mean is 0, the standard deviation is 1, but now our z-value is 1.43. Hit compute, and we're still leaving this at less than or equal to, because that's what we have in our picture. And then this shaded area now is 0.9236.